This video is going to show you 3 examples of how to find the exact value of trig functions given they're not the special triangles. And the special triangles I mean are like 30, 60, 90, 30, 60, 90, and the 45s. Those are the main ones. 90's not really one we'd use, but the 30, 60, the 45, technically we could use the quadrantal also. So I put the 2 triangles up there because I'm going to use those to help me figure out my values are. But you can, on my notes that I gave you, there is the unit circle. You can clearly look at the unit circle. I didn't use that a lot in class. I used the triangles. But you can use the unit circle. I have my formula sheet handy so I know what to look at. So let's do these. Again, we are finding the exact value. You are not using a calculator to do these because the calculator won't give you an exact value. Your exact value means you probably have a radical in it or they're fractions. Okay, so the sine of 45 isn't one of the ones we know. So I sit here and I think, what 2 angles can I add or subtract to get 75? And I'm looking at these guys. I'm thinking, what 2 numbers can I add or subtract to get 75? So my brain goes to 45 plus 30. And it doesn't matter. You could have said 30 plus 45. That doesn't change the problem. All right, so that is the sine adding. So I have to now write the formula because I can't find the sine of each of those 2 numbers and add them. It doesn't work like that. Sine is not distributive. You don't distribute it in, say sine of 45 plus sine of 30. That doesn't work the same way. So a formula was made up, and the formula for adding says to write sine of the first angle, cosine of the second, and then I'm going to say plus. When you do the sine, the operation stays the same, and then it's cosine of the first, sine of the second. So it's sine of the first, cosine of the second, adding matches, and then I'm going to switch and go cosine of the first, sine of the second. So notice each of the trig functions use the angles at a different spot. I'm going to notice that for sine, the adding stayed. And then I just got to kind of remember the formula. And you have a formula sheet, so use it. All right, now I'm going to use my knowledge because I know what the sine of 45 is. So I look at my 45, 45, 90 triangle, and I'm here at 45, and I know that sine is opposite over hypotenuse. So it's opposite over hypotenuse, which I know is 1 over radical 2, but I also know that I have to clean that up. So I'm going to just write that here, 1 over radical 2. All right, but I know that I can't leave it like that, so I know I'm going to multiply by radical 2 over radical 2, and I know the sine of 45 is really radical 2 over 2. We've done that enough that I shouldn't have to go over that again. Okay, cosine of 30, so I'm going to go to my 30, 60, 90. I'm standing at 30. Okay, cosine is adjacent over hypotenuse. So this one worked out nice because the hypotenuse is 2, and it's okay to have a whole number in the denominator. So for this guy, I'm going to say radical 3 over 2. And those guys are going to be multiplied in a second. All right, now I'm going to jump and I'm going to do cosine of 45. Cosine of 45 is the same as sine of 45 because it's adjacent over hypotenuse, whereas sine was opposite over hypotenuse, adjacent over hypotenuse. And it's 1 over radical 2, which I know simplified is radical 2 over 2, so I'm just going to write that down. So radical 2 over 2, and then I'm going to do sine of 30. I go here. Sine is opposite over hypotenuse, which is just 1/2. Whoops. Opposite, I'm at the 30. Opposite over hypotenuse, which is 1/2. All right, now I just do my math. I multiply the numerators. I can multiply radicals with radicals, so that gives me a radical 6. Multiply the denominators. 2 times 2 is 4. And then I'm going to say plus, multiply the numerator. Radical 2 times 1 is radical 2. 2 times 2 is 4. So I can write this as 1 fraction because the denominators match. So that's just going to be radical 6 plus radical 2 all over 4. Do not add the 6 and the 2 because radicals need to match in order to add them together. So that is my final answer. So the exact value of the sine of 75 is radical 6 plus radical 2 all over 4. You'll find these answers all look a lot alike when we do these. All right, so the next one, I'm going to do cosine of 15. And again, I'm thinking using my angles up here, I'm thinking, how can I add or subtract to get 15? So I'm going to subtract, and you could probably do this a couple ways. So I'm going to do cosine of 45 minus 30. Okay. You could have done 60 minus 45. Doesn't matter. So I'm going to do that one. So now I'm going to use my formula for cosine. All right, because again, I can't distribute. I can't find the cosine of 45 and then find the cosine of 30 and subtract them. It doesn't work like that. The trig functions are not distributed. You can't distribute like that. Okay, so the cosine function says do cosine, then cosine, and then sine and sine. And in between, I want the opposite operation. So I'm going to go cosine of the first times cosine of the second number. And it's adding, so it's subtracting, so I want to add for this. Cosine's the opposite operation. And then I'm going to do the same thing with the sine. So I have sine of 45, sine of 30. All right, now if you were to switch these two guys, that doesn't really matter because you're multiplying, and same thing here. So if you wrote those in different order, it doesn't matter. The cosine needs to be here and the sine needs to be here for this to work. I have to be honest with you, since you're adding, if you put these first and these second and you added them, it's not going to matter either. Okay, so now I've already found a bunch of these already. So I already know what the cosine of 45 is. Cosine of 45 we did right here. Cosine of 45 is right here, so that's radical 2 over 2. Okay, the cosine of 30 I did up here already, so I'm just going to reuse what I had, is radical 3 over 2. All right, and then I want the sine of 45, which, again, right here. So I know that's radical 2 over 2. And I'm going to do it times the sine of 30, which I know the sine of 30 I did right here is 1/2. So we have the same values. That's the nice thing about this thing, is we keep getting the same values over and over again, and we just put them in different places. So knowing what all these are can be really helpful. All right, add multiplying. So I get radical 6 over 4, and then it's going to be plus radical 2 over 4. Wow, looks just like the last question. Radical 6 plus radical 2 all over 4. That's my final answer. So now, the reason these guys are the same answers is we haven't discussed this, but if you look at the sine and the cosine angles, it's 75 and 15. 75 plus 15 are 90. So if sine and cosine happen to be complementary, which means they add up to 90, so if sine and cosine, if you have a sine and you have a cosine and they're complementary to each other, they're going to have they're equal values. That's just kind of a bonus round for you. All right, so if the sine and the cosine add up to be 90, whatever their exact values are will be equal. All right, we're going to do tangent next. All right, with tangent ones are usually a little bit harder because there's a little more math to do. It's not harder coming up with the tangent value. It's just usually there's a little more math to do. So let's see how this one goes. So I have 165. Again, 165 isn't one of those good angles I can do something with, but I can try to think of ways to add two numbers together to get 165. So this one, what I'm going to do is I'm going to use 45 plus 120. And I know 120 isn't a 30, 60, or a 45 angle, but 120 is one of the reference angles that we used before. And its reference angle is technically the 60 degrees, if this is what I'm talking about. So remember, 120 is over in this quadrant, 2. So it's over here. And if we found the reference angle, so this is the 120, but the reference angle is 60. Okay, so 120 goes with 60. Okay, because I did 120 minus 180 right here, that's what I was looking at. So 120 and 160 have the same value, except the signs might be different. So all students, so in the second quadrant, tangent's negative, so 120 has a negative value that we got to remember to do. All right, so that's the main thing we got to do. So it's the same as 60 in its number-wise, but we're going to make it negative. Okay, so tangent is another formula. This one's a little bit different. So I'm going to go tangent of the first, and then it's going to be plus in the numerator. So tangent of 45, and then it's going to be plus tangent of 120, and that's all over 1. And in this case, we are going to be subtracting now. So we switch the sign from what it was, and then it's going to be, you're going to multiply the two guys together. So it's tangent of 45 times the tangent of 120. Again, if these two guys here get switched, it doesn't matter because we're multiplying. If these two guys get switched, it doesn't matter because we're multiplying. All right, but what does matter is you need to have a 1 here, and it should be minus here. It's got to be the opposite of what you had above. And it's this and this are the same, but then you get to the denominator and it's the opposite. Okay, so now we're just going to plug in what our exact values are of all of these to get the answer. So the exact value of tan of 45, so I'm over here at 45, and this is a nice one because tangent is opposite over adjacent, which would just give me a plain old 1. So tangent of 45 is 1, and then I'm going to say plus. Now we said 120 is the same as 60, but it's in the second quadrant, so whatever I have is going to be negative. Okay, so I'm going to write that negative down so I don't lose it. And I'm going to look at the 60 triangle for tangent. So the 60 triangle tells me tangent at 60 is opposite over adjacent. So opposite over adjacent. So it's radical 3 over 1, so it's just plain old radical 3. Okay, so far this one is actually not working out to be too bad because we're not going to have some crazy fraction that we have to undo the radical. All right, now in the denominator, I have 1, and then I'm going to say minus, and tangent of 45, we already found out that was 1, and then it's times the tan of 120, which we know is negative radical 3. So the nice thing about doing tangent is you're already going to have the numbers. Once you did the numerator, you're going to have the values for the denominator. All right, so I clean this up and write this correctly. It's going to be 1 minus radical 3. And then in the denominator, I'm going to have 1, and then 1 times the negative radical 3 is still negative, but a negative and a negative turn into a positive. So I get 1 plus radical 3. Okay, now at this point, these guys look really similar, but they're not the same value. Okay, so don't cross anything off right now because they're connected. Binomials are connected by the plus minus, so this is actually just this 1 minus radical 3 is a number. 1 plus radical 3 is a number. It's not two separate numbers that you can take apart. This is one number, this is one number. Again, not two separate numbers. So we cannot leave a radical in the denominator. So this is where it's a little more complicated. So to get rid of the radical in the denominator, we learn that we want to multiply by the conjugate. So the conjugate is this value, but switch the sign. So we care about the denominator, and we care about the sign of the denominator. So this guy needs to be changed to the opposite, and that's what we're going to multiply by. So we're going to multiply the numerator and the denominator by 1 minus radical 3. Okay, it's not the numerator that matters, it's the denominator, but we have to do this in the both the numerator and the denominator. Okay, this works again because 1 minus radical 3 over 1 minus radical 3 is really just 1, and anytime you multiply something by 1, you get the number back. Okay, so quickly, in the numerator, you're going to FOIL it. Okay, so 1 times 1 is 1. I'm going to jump over here. Minus radical 3, and then minus radical 3 times 1 is negative radical 3, and then negative times negative is going to be positive. Radical 3 times radical 3 is radical 9, which I know is 3. All right, let's stick to cleaning up the numerator. So I got 1 plus 3 is 4, and then I have minus, I have two radical 3's, which is 2 radical 3. Okay, in the denominator, the trick for the denominator is you just multiply the first minus the last, and that will give you what the final answer is. So the first, these are the first, that's 1. This only works when you're doing the conjugate, when the signs are the opposite. So 1, and then I'm going to say minus, and then I'm going to go radical 3 times radical 3 is 9, which is really 3. And that's going to give me 4 minus 2 radical 3 all over negative 2. Now, the easiest thing to do at this point is look for numbers so I have this guy, and this guy. Okay, they all have a 2 in common, and technically they all have a negative 2 in common if you want to take out a negative 2. So if you can reduce everything by 2. I'm going to reduce everything by negative 2. So that's going to give me negative 2, and then a negative and negative turns into a positive here, positive, and then take out that 2 radical 3, and then if I reduce out that, it's just going to be over 1. And that is my final answer. So tangent ones require a little more finesse. They require a little more algebra to do that correctly. So take your time with that and do that correctly. That is it. So I gave you a sine, a cosine, and tangent. Find an exact value. Again, you don't want to do these on the calculator because they will not give you the exact value. They will give you a decimal, which is never an exact value. Radicals, fractions, exact values. Good luck.